Professors, distinguished guests, ladies and gentlemen, good morning in United States, good afternoon in Netherlands, and good evening in Taiwan. Okay. Welcome to NEEMEC e-forum, theme-based engineering education in practice and post-pandemic strategies. My name is Jung-Ho Chen, project leader of NEEMEC program and the host of this forum. My co-hosts are Professor Kuiyan Zhang and Fu-Lin Yang. Please say hello. Please.
Hi.
Hello.
Today we are extremely honored to invite Professor Hans Wehrmann, who is also the Director of Education of Technology University of Delft, Netherlands, as well as Professor Margot Vigen and Professor Charles Kim of Bucknell University from United States. Let's welcome them. Hi. Okay. Before we continue, I'd like to take this opportunity to congratulate Professor Kim for his recent promotion. This is a very special forum. Not only that we are connecting people from 3 different countries across 3 different continents and over such a broad time zones, but also through this kind of special concord. First, let me show you our program today. We will have 3 topics by our invited speakers, and then an open discussion period to be hosted by Professor Zhang. We met Professor Wehrmann and the 3 hosts visit Delft University in November of 2019. He gave us such an enlightening talk about their engineering education system. Today, everyone in the audience can hear from him face to face. Professor Margot Vigen and Charles Kim have come to Taiwan before and participated in a workshop held in Kaohsiung last January. I think many of our audience have met them before. Today, we are very pleased to have 3 of them gathered together in this forum. Without further ado, let's welcome Professor Wehrmann. His topic is Master of Science, Redesign for Civil Engineering and Geosciences, TU Delft, from strategy to course syllabus. Professor Wehrmann, thank you.
Yeah, thank you, Mr. Chairman. I hope my audio is okay. We're on. Okay.
Good.
Thank you very much for inviting me to reveal some of our discussions in the faculty about new course modules. This is just a working title, and I will demonstrate to you what is behind it. As already introduced, my name is Hans Welleman. I'm the Director of Education for the Faculty of Civil Engineering at TU Delft. I'm also teaching structural mechanics, so I browsed around the NTU campus and I found this sign which revealed the Division of Structural Engineering of the Department of Civil Engineering, and that's exactly where I come from. So I'm a civil engineer by training, and I'm teaching structural mechanics next to being the responsible person in the faculty for all our education. So Delft may be familiar to you, at least for the delegation who visited us. We're in between Germany, as you can see to the right. This is the Hamburg area. Here on the south, you see Belgium with Brussels and Antwerp. Amsterdam in the middle here. And Delft is a small provincial town with a huge university. We are 1/3 of the total population of the Delft community. So that's big. I think compared to Asian universities, we're relatively small. For those who are less familiar with the Netherlands, you see here the huge delta area in the Netherlands. And for that reason, we are so famous in hydraulic structures, flood protection, etc. You can also see here a freshwater lake, a huge freshwater lake, which is also our drinking water reservoir. So that also gives the scope for our civil engineering. It's a lot about water and protecting the country for flooding. So actually what I want to discuss with you or to show to you is the redesign of our master programs in our faculty. For that, I will give a brief update about the size and magnitude of our faculty to give the scope of this project. Currently, we are more or less in the middle of this process, and it started just shortly after I met the delegation from Taipei. So that was in November 2019, and we started this project in April 2019. So we were just a few months underway. Now, of course, it's July 2021, so we are well advanced. I think it's very appropriate to share this with you, although I must say that part of it is still under construction, so it's not a settled program yet. So we are part of the university, which was founded in 1842, and we are one of the biggest faculties in Delft. As I said, 28,000 students in Delft. For our faculty, we serve about 3,500. Yeah, so that's the amount of students, just bachelor and master students, so not the PhD students, only our students in the bachelor and master programs. The university is a rather complete technical university. You can see that here from all the faculties listed. We have architecture, electrical engineering, industrial design, aerospace engineering, technology and policy, applied sciences and mechanical engineering, maritime engineering and material engineering. And the civil engineering is here in the gray area combined with geosciences. So that's where I'm from. The scope of our university is, since it's a technical university, it's not fully curiosity driven. It's also not fully application driven. It's in the middle. And it's also in the middle between fundamental and pragmatic. So we need fundamental research, and for those parts which we cannot find elsewhere, we do it ourselves. But we're not primarily in fundamental research because we are training engineers. Large research facilities. For those who visited Delft, I think it's interesting. And we're building on them. So if you'd like to know more about it, you can find it here on the website. But just to give an example, we have a experimental nuclear reactor on the campus, and also facilities for hydraulic testing, wind turbines and wind tunnels, but also nanotechnology. So it's a full scale of technical innovations. Our CEG faculty consists of 7 departments. They're listed to the right, and that from those departments you can see already a little bit the scope of our portfolio in research and education. You see 2 departments related to water, hydraulic engineering and water management. 2 departments related to materials and structures. So you see materials, mechanics, management and design, and a department on engineering structures. These 2 used to be one big department, but that grew too large for the organization, so it was split. And we have a department on transport and planning and a geoscience engineering. So all the issues related to foundations, etc., can be found in geoscience and engineering, but also issues about geothermal energy, petroleum and mining. It's all in this department. And we have a department on geoscience and remote sensing, a lot about data acquisition, radar technology, satellite observations from the Earth, and also climate-related issues. So that's all in one faculty. Now, of course, we are linked in all kinds of research initiatives, but I leave that for now. Based upon the scope you already observed a little bit, we offer 6 educational programs, 2 bachelor programs and 4 master programs. And the biggest program is civil engineering. So we have a bachelor program, civil engineering, and a master program, civil engineering. And we have an applied earth sciences program in both bachelor and master. The civil engineering program starts in Dutch, and so that's not an international program, but all master programs are international programs. And the applied earth sciences program in the bachelor is also an international program, so that is English taught. The reason we do not offer civil engineering in English is that we will be flooded by students and we can simply not handle it. So that's why we limit it to the Dutch world, so to speak, and that works perfectly all right. Apart from these 2, we also have transport infrastructure and logistics, construction management and engineering as master programs, additional master programs. These are more generic programs for which practically all technical BSc diplomas are giving an entry ticket. So a lot of students can opt for these 2 as well. Apart from these fixed programs, we're also heavily involved in MOOCs, online education, professional education, so that's called Prof Ed, and that is offered by the University Extension School. That's a new initiative where you can find all our online education. And of course, we also have tailor-made masterclasses for companies or specific questions out of industry. So this is our current portfolio in education. The size of the faculty, well, it's about 500 academic staff. You can see it here split in professors, associate professors, assistant professors, and researchers and teachers. That's the other scientific staff. And then we have a separate number for the PhD students. So including supporting staff, it's well over 1,000 people. So that is civil engineering and geosciences in Delft. The number is a little bit outdated because we are heavily investing right now, but for the scope and the size, this is enough. So with 3,600 students roughly, you can see here that almost 2,500 students are in the civil engineering programs, and the 1,100 other students are divided over the other programs. So construction management, engineering, and TIL are relative small programs with an influx of around 100 students per year. And the applied earth sciences program is also a limited program with around 100 students per year influx. You can also see that we are able to attract a lot of female students compared to the past. This is a relatively good number, about 30%. When I studied, we were around 4%. So, and of course, my color of my hair is gray, so it's long time ago. But actually, this 30% is more or less a barrier. We are at at a constant level of 30%, and we cannot or very difficult further increase. So it has to do with the composition of the number of female students within our education system for technical studies. But it is for us, it's an encouraging number, but we would like to have more, of course, towards 50%. Is there a driver for change in our educational portfolio? That could be a serious question, of course. And if you just look at the QS ranking, there is no driver, because you can see that the Technical University in Delft for civil engineering is on position number 3. This was the 2021 list, but you can look for the similar lists in previous years. And every time we appear in the top 10 ranking, as long as I'm in educational management, I observe that. Of course, it has nothing to do with me, to be clear. But it's very nice to see that our program is very well respected internationally. Of course, this is also one of the reasons why we attract so many students. So there is no driver for change from an international perspective. But in Delft, of course, we think we are the best in the world and we want to be in the league, in the premium league. So from a strategic framework, we started a discussion how we can keep our front-running position in the world. And this strategic framework is here visualized in a very nice sketch. You should take it with a little bit of humor, of course, because this is an exaggeration. Well, you can see we're on the top of the world, but maybe we are. And we are focused on design, engineering, and science. And of course, we're working on societal impact. So that's why we're on Earth, so to speak. We're also agenda setting and we are steering. So you can see that here. We are leading engineers and researchers, and we set the agenda for the future. We are an all-inclusive community of excellent staff and students. That's what we want to be. So from this strategic framework, all the departments got the task to rethink their position in the world, in the educational market, in their field of operations with respect to research. So combined with this thinking about strategy, there was also a new vision on education. Well, you can find here a lot of buzzwords. I think you're all familiar with it. It's a list of things we have to consider and to pay attention to in our education. I think we all fully agree, but we also feel the problem how to deal with all these aspects in our education. Because if you do the one thing, you cannot do the other thing sometimes, or maybe we can find clever solutions for that problem. To mention a few, of course, we are well known for thorough and in-depth disciplinary knowledge. We want to keep this, but we should also work on multidisciplinary aspects in our programs. Our students should be competent in solving real life challenges and real life problems. They have to be creative and inquisitive, so they have to be also proactive later in life. We should not train them for the first job, but we should give them so much with them that they can train themselves and learn lifelong. So it's about lifelong learning skills. We need to find a good balance between theory and application. We cannot stuff our students with only theory because they should be able to solve the today and tomorrow's challenges. Of course, students must be made responsible for their learning. And so you can see here a number of things we think are very, very important in our education. Last but not least, also that our teachers are not there only to provide info, but they should empower learning of our students. So there must be feedback and there must be initiation of this creative and inquisitive attitude from our students. So it should come also from us as teachers. So we started at the faculty thinking about our own position and also our educational portfolio. I will not discuss it in detail because otherwise we are out of time. But from this outcome of our strategic discussion, which took us from October 2018 till February 2019, we discussed why we are needed as a faculty and what is our contribution. And we work in the natural living and built environment. That is very clear. And you can go left and then you enter the more or less the natural environment, the system Earth, the resources, the natural resources. So this is our area of applied earth sciences. You can go right, and then you enter the area of the built environment, the infrastructure, which is more on the civil engineering side. In the middle, however, we also defined the living environment. And lots of aspects are relating to the living environment have to do with the environmental issues. So the sustainability goals from the UN, and we are working on that at this moment in primarily each of the two programs, Applied Earth Sciences and Civil Engineering. But the idea is to focus more on these environmental issues, and we started therefore the debate whether it's possible to open a new master program in environmental engineering. So that was the outcome, more or less, also from this strategic framework. We started rethinking our educational portfolio and decided that there is actually a need for a new master program. Here below, I think this also characterizes our university. We want to understand the phenomena, we want to be able to intervene and to improve. So quite a powerful strategic framework. So we formulated our ambitions on education, and we also clearly wrote down this in our vision on education from the faculty. I leave the details for you. We also have a few ambitions for our staff and our faculty. So who do we want to be as a faculty with up-to-date facilities, of course, and you can see here with excellent reputation on education, we don't want to lose this reputation, so it's important for us. We want to be the best institute for engineering courses in our field, but also balance teaching load and a healthy student-staff ratio are important aspects for us as a staff. So now the question then is, how do we get from strategy to program? And I think we can spend half an hour, I think, about this, and we are in the middle of this process. So I want to take you with me on a journey we made now in the past 2 years on how to realize new educational programs for our master education. So we first defined the most important project in our faculty, and that was the project number 1, P1, initiated by our dean and the board of the faculty. So this is a strategic decision to start with a group who is pulling this development. And I was nominated as the project leader for this project, so from my responsibility as Director of Education. Of course, our project goals are to realize the ambitions on education and for the faculty, as I just mentioned. And we also put a statement that we would like to start with our new education in September 2022. So that was the calendar was set. Of course, this was all just prior to COVID. So this was already a very challenging calendar. So then we started a discussion in the faculty about our portfolio. And first of all, we had multiple sessions with the board of the faculty. So the management team members, those are the head of the departments, with the dean, myself, and the head of finances and HR. And from that, we had a few sketches, and then we gave these sketches to the project team, which was built out of the young tenured staff. We selected as a management team, more or less, the members of this team. And we specifically opted for the young tenured staff because we want to have new ideas in our education. What would be the trends? What are the topics we should pay more attention to than in the past? Because we are from a system in which we just give or hand over our courses from colleague to colleague when we are being succeeded. And actually, that is not the right way to come to a coherent educational program. So to break with this, we decided to initiate this P1 team of young tenured staff, which appeared to be a very, very good decision. So they started debating our portfolio, and then they organized walk-in sessions with the rest of the staff. So we had big meetings split in several sub-meetings to make sure that the entire staff, academic staff in the faculty, was connected. So you have to realize this is a few hundred people. So this is a huge task to do. And the project team P1 itself consisted of about 25 young staff members. So the outcome, I leave a lot of the details away, but the outcome was to explore 3 new MSc programs, 2 the existing civil engineering and applied earth science, but then renewed, so with a different scope, different structure, and 1 new program on environmental engineering. So by then, we were advancing summer of 2019. In this exploration of the possibilities, I can show you this slide, which we built during all these discussions with the staff, and it shows or reveals the current situation in our education. And we used the tree as a symbol to show you all the different tracks in our education, our master education. Of course, we have shared roots, which you can see here below, based in the societal challenges we are working on, but also the core disciplines we defined in our faculty, and also the core methodology we observe that everybody is using. And from that, you can see that there are actually 2 trees, civil engineering and applied sciences, but then they merge and they branch, and it's a bit of a wild figure. And this tree was just growing for decades. And every time we made a new branch, which means we had a new track, and we never discussed really why we needed this track. Sometimes it was just because we had highly experienced people, or we had experts in a specific field. So we started also education in this field, but we really never debated and connected these parts of education to the original stem of the tree. And debating this, we found that there were a lot of overlap. We also had doublings in the programs, and we missed the debate on the why. Why did we constructed our programs in this way? Of course, content-wise, all of these parts are highly valued, so they're top-ranking tracks. But actually, they are all more or less isolated from each other. We could easily opt for individual master programs for each of the tracks, because in some cases, the only course they shared was ethics, to be very rude. So in that sense, we really had a fundamental debate. What is civil engineering about, and what should be common in civil engineering for all civil engineering students? And where do we deviate or focus within civil engineering on specific elements? And so also for all the other programs. So this was a more fundamental debate on the existence of the programs. This was very, very much a revealing process. It took us a long time. So we had to define the position of each of the programs from scratch, and that's why we decided to do this for all the programs, also for those existing programs like civil engineering and applied earth sciences, because we want to have a comparison in the development between all the three programs. And now for the new program, we had to go through a few hurdles. We need permission from the board of the university. We need permission from the ministry to start a new program. And this program has to be accredited. I think you are all in more or less a similar system. So that is for the new program. But we decided we want to do this for the existing programs in much the same way. So we go from scratch and we define position papers for each of the programs. Context, scope, the societal relevances, the connection to our research, how about the job market, is it feasible to have this program, and then an outline of this program, a sketch, what it is about, and how is it structured. For that, we needed approval of the Board of University for the environmental engineering, the new one, but we did the same for the other two. And then this phase ended in June 2020, so a year ago. And that was, I met the delegation from Taiwan, I think somewhere here in the midst. So we were well underway then, but by now we are much further ahead. We also have now the full detail of the three programs. So how did we advance from this stage to the next stage? That is what I want to reveal to you as well. To find an outline of the program, we needed a framework to structure our master education. And I think you're in a similar debate. How can you mold your education in a more thematical approach, where you use projects and where you put things which are connected to each other, more or less next to each other in the program? So that was a discussion we had as well. So again, we started a debate between our colleagues, and we asked them to freely discuss the why, the what, and the how of each of the program in a way they think would be appropriate. So this left us with a huge pile of opinions, of course, but from that we could more or less see what is the common reasoning for specific choices. We also made a distinction between skills which were needed, so humanities and communication skills, the professional engineering skills, and the more scientific and academic skills. And people were freely asked to just write down anything they would come up with. So this was also an extensive phase. And then we started with an idea how to give more structure to our programs. And we came up with a different type of components of our education. And we started with the smallest block, a brick, so to speak, which is called a unit. You could see this as the old type course of 3 to 5 ECs. But we are not speaking any longer about courses, because our bigger module entity is the module, the next one, which is built out of units, and these units are thematically linked to each other. So that's why the unit itself is not really a single course. It could be, but it is always embedded in the module in a theme. Modules can also have a specific purpose. So it's not only thematical, it could also serve a specific purpose. For instance, a module for all students in a single track. So what is the compulsory part of the track? We put it in one single module. All the students within this track will follow this module. So that's how we grouped our education in modules. And then the modules can build up to a track, and we can have several tracks in our program. Of course, linked to this debate, we also started the discussion of how many students do we need then for a program, for a track, for a module, and for a unit, to think about efficiency and feasibility. We cannot teach for 3 students. That's more or less the common idea. So that is a part of the framework. Another part of the framework, which is very interesting, is how we can divide, but also link the different programs to each other. And for that, this one was coming up through in a brainstorm where we put the 3 master programs here in 3 different colors. So we have applied earth sciences, civil engineering, and the environmental engineering as the 3 programs. And they share the common roots on modeling, uncertainty quantification, data handling. So we decided that one of the modules will become mute, as we abbreviated it, so short for modeling, uncertainty, and data engineering. And all our students will follow this mute model. This module is therefore thematic, but you can imagine that students who opt for applied earth sciences have different interests than students from civil engineering and environmental engineering. However, this mute module will have the same objectives for all students, but with different type of projects. The projects are linked to the context of the 3 programs. So we will set up I think, quite a complex module in which a lot of staff will work together, because in this central module, all our 500 students from civil engineering, environmental engineering, and applied earth sciences will follow the same module, but with a different set of projects which are related to their field of interest. So that will be a very exciting new element in our curriculum. But I think it's also the new element in our curriculum. We're moving more towards handling big data, artificial intelligence, because if all our students have the same starting point, we can also make use of this in a later stage of our master education. So later on, we can also develop shared modules where students can have more advanced modules on data and uncertainty. To make that a little bit clear in this picture, you can see the crosses. So there are links between the programs. One is here missing. That was not on purpose. So there should be a cross here as well. And you can see crosses between tracks. So we want to make links between the programs. We call them crossover modules. They will be placed in the 2nd year of our master education. And then students will work on a common theme. Well, you can think of, for instance, artificial intelligence and data. All students from the 3 programs could be interested in this one. And then this one is working on the interface of each of the 3 programs. So these crossovers are actually an extension of more or less the idea of doing things more and more together. Of course, within the program, you can also see that we can have a focus on different tracks. So within each of the programs, students will opt for electives which are linked to a specific track. And we go no deeper than a track, because we still want to keep the entity of the program and not to dive too much in a specific specialization. So that means that there is also always a fixed program for all students in a program. Then there is a fixed program for the students within a specific track, and then there will be electives in the track. And next to that, there will be also general electives, which students can follow internationally from different universities, or they can follow education at different departments. So that's another framework, the basic setup of our 2 years MSc. And you can see that in the 2nd year of the MSc, we make space here. We reserve space, a full quarter, for either interdisciplinary projects within the TU Delft. So we have a project which is called a joint interfacultary project, the JIP. initiated by mechanical engineering and aerospace engineering, and we from civil engineering also join. These are company-driven projects, open-ended projects where students from different backgrounds can work in a multidisciplinary way on solutions. Our students can also opt for in-depth specialization, so more courses, and these are actually more single courses in a specific field of interest. And then in that second year, you can see also these crossover modules, which links the different programs. In the first year, you can see a yellow block in the first quarter, semester 1, where we start with this mute program. So all students are starting with data, uncertainty, and modeling. And that's not the only thing they do. They also start in their own program. So they do the common part of civil engineering or applied earth sciences or environmental engineering. The full quarter is based upon a fixed program. So students only start making choices in quarter number 2. So within a program, then they have to choose for a specific track, and then they go on with that track and they make specific choices for electives in the track. So this is the basic structure for all the 3 programs. We needed this in order to be able to fill in all the modules. So the end result is that we have a fixed format for the entire program. We have a format for the electives, the crossover, the links between the programs. So a lot of our objectives can be met with this structure. Needless to say that this was a big discussion. Yeah? So we needed a lot of time to decide on this. And then, of course, our staff went berserk and they started to make an inventory. And I just show you here on the fly what happened in, for instance, my own group with engineering structures and structural mechanics. We made an inventory of all the topics we teach, how they are linked, how we can regroup them into thematic parts. And that was a hell of a job. But this was never done before. We never discussed with colleagues what actually we are doing. Everybody had their own niche. And well, you could handle the same topic as your colleague and never know for 20 years. That's over now. We made a full inventory. And from this, we could really clearly define on a modular basis what is connected to what and should be taught in a specific order. So leave out all these details because it's just to demonstrate to you the type of discussions and phases we had to go through and to come up eventually with, for instance, the basic setup of our civil engineering program. You can see it here. It has a number of tracks, 6 for this moment. Within the track, we have modules which are called A modules and B modules. So these are the fixed thematic modules. And a little bit depending upon the number of students in a specific track, we offer more choices. So for instance, to see how it works, structural engineering is a big track, a lot of students, well over 100 students. So we offer 3 types of A modules. Students have to pick 1 out of 3. And then in the next period, they can pick a B module. So they're within the structural engineering domain and they have these electives. But it is not a choice of courses. It will be a choice between modules. So it's always in a modular way. And that means that we have bigger parts of education which are clearly defined, which have specific objectives, and these objectives are linked to the objectives of the total program. So we went through the whole tree of why are we doing this in our program. You can see in the second year that we have the elective space, we have the crossovers, and then we have the master thesis, which is a full semester. And the master thesis is prepared in the quarter just prior to the master thesis. So actually the master thesis is in our system 35 EC. I already mentioned this, and this I think is also an important aspect of the total voyage we made. We really start thinking from learning outcomes of the program. That was the highest hierarchy or level. So what is it that our students should know and learn or be able to do? So the ELOs, the intended learning outcomes, were defined at a program level. And then we also did that on a specific track level, module level, and learning activities level. And they are all linked to each other. And in the document we have so far for civil engineering, applied earth sciences, and environmental engineering, we really made all these tables where we linked all the objectives of the elements of learning activities to module level, the modules to the track level, and so to the program level. So we can always clearly see to what extent we offer in our program specific elements. What is also important is that if you want to change your education, you can change easily on a modular level. You just cut out one of the modules, you look at the objectives of the module, and as long as you satisfy these objectives in your new module, you leave your total program unattached. So it is a better structure also to change and to modify. We really want to be adaptive to new research areas, to new developments, and our program was too much fixed. So that is what we now changed based on also this thinking of from the level of learning outcomes all the way down. So it's a long sit, but let's complete or conclude a little bit more where we are on this roadmap. We started with this definition of the problems and what we would like to design. We created the position papers for the three programs. It was approved by our board of the university. Then we moved to the actual curriculum design, and we delivered this summer for the three programs the detailed plans for the programs. So we're now in a stage that we can submit the papers to the ministry for approval for the new program. And then we have to go through the accreditation process, which will take place in December this year. And then hopefully in January, we get the green light for environmental engineering. And then next year, in September 22, we will start with the new education. We're still not there, but the curriculum design as it is now, for your perspective, the team delivered 350 pages for the civil engineering program with detailed plans of the module layout and the content which will be treated. So this is a long way, and you can see that it takes us a lot of time. But now, the coming year, we need to create all the new lecturing material. Of course, we can use a lot of material which already exists, but we will have a reshuffle in parts. So we have to make teaching teams and to set up the modules. So that is the phase we're now. We have to go to a syllabus. So we upscaled the project. At the moment, more than 150 staff members are involved in this project, and that's why it's the most important project in the faculty at this moment. And as I discussed, we're at this moment, June 21, we have the approval of the board now, and we submit it to the ministry. Linked to this bigger scale in the project, some aspects which are important as well, making a stakeholder analysis for everybody who is involved in our education, both internal in the university, but also external and then provide them with the information on this project and also input we need from them. We work with terms of references for all the teams to handle the project. So we have a project-based approach in getting explicit expectations from each and every group. Of course, we're working with academics, so don't think that this is all going well. So it causes enough problems, but at least we do have a project-based steering. And you can also see that we started initially with the younger staff, but then of course we cannot put all the load and burden on them because they have a lot of other obligations in research and building their own groups. So senior staff is now also more involved. And we use frequently the management team to settle certain issues and to make decisions, and then we can move on. Of course, we also have extra help from educational support with advisors on education. Maybe in due of the time, you can see here what such a project asks from the faculty. So we have here below, we have the actual teams who are working on each of the parts of the program. You recognize here the program Applied Earth Science, Environmental Engineering, and Civil Engineering. So these are the actual teams for the programs, but we also have a team for crossover development, and we have a special team for this common module in modeling, uncertainty, and data. So the MUDE team, as we call it. All of these teams have sounding boards filled with staff who are not directly connected to the development teams, but of course they do have an opinion, and we can use them to find how our plans are landing, and they give feedback from which we can improve our plans. So looking in the rear view mirror, we can see that we are now at a moment where we have detailed modules. We still have a year to go before we start with the actual new education. So we will have a tough year because during this period in March, we were of course also suddenly surprised by the COVID, and that put a lot of stress on this project. On the other hand, doing everything online in online meetings also was a huge benefit because it was much easier to get in contact with each other in a very high frequency. So it's not all negative, and I must say my colleagues are really stressed to the end, myself as well, but we are very, very much committed to this project. Actually, the whole faculty is. And if I look from this perspective, also I hear from our younger staff that they now understand what's going on in the faculty, who is doing what, and they met a lot of people they never met before, and they are sharing now also in research the things they found out during the talks about education. So there is a huge spin-off in the faculty in getting more coherence. So that's all very, very positive. What helped us? Well, repeating to everybody why we do this is really, really essential. The project-based type of working is very, very essential. Of course, building coalitions of the willing in the beginning where you need a group of people who really see the importance of this. It's not automatically taken by everybody that we really have to change. I demonstrated that with you by showing you the QS ranking. So you can imagine the questions from the colleagues. Why should we change? We're number 3rd in the world. We're the best. Yeah? So rethinking your own position is really important. And we have, of course, our full commitment of the dean and the management team, which is essential sometimes as well, because you really have to push forward. Sometimes tough decisions has to be made. And then it's very important to have the support of the dean. Well, last but not least, special attention Detailed planning and the workload is still an issue for us. We really want to improve on the workload for all staff members, and we still have to do some serious work on that. We are understaffed in our resources to support this project, so that is also still attention. And if you ever go for this, make sure you have enough resources also to support such a project. And communication and stakeholder management is really vital. That is still taking a lot of attention. I think I'm almost through, Mr. Chairman. With your permission, I would conclude here. We're not there yet. I hope within a year that we open with a new program, and I'm very anxious whether it will run as planned. Yeah. Thank you.
Wow. Wow. This is so impressive. Yeah, thank you so much for the informative and insightful presentation. Our second speaker is Professor Charles Kim. His topic is remote teams during a pandemic, the good, the bad, and the ugly. Let's welcome him.
Okay. Fantastic. It's a little bit challenging working off of multiple screens. I want to thank Professor Chang and Professor Chan and Professor Yang for the invitation to speak with you today. Albeit I'd rather be in person with all of you, but I understand the restrictions, of course, that we're facing due to COVID. I'm going to be talking today about remote teams during a pandemic. And I'm really glad where Professor Wellerman left off and how well their team worked together and how well their team is going to have to continue to work together. And I hope that as we have this discussion today, that you'll see the relevance of what we're talking about today with teams, not just for capstone design or for small teams, but for teams that are in person, teams that are larger perhaps, teams that are not just students. I want to give you a sense of what we did this year. So this year at Bucknell, due to COVID, we had the possibility of being remote, hybrid, or in person, all possible, meaning that we could have students who were in person. We could have times where students, whether voluntarily or involuntarily, were in quarantine. And we also had the opportunity for students to join us from home. All at the same time, and we had to be ready for that at all times. And in fact, through our 30 weeks of instruction this year, we had 4 to 5 weeks of complete remote instruction because of COVID. All of that considered, we still held our capstone design class in much of the same way, in some ways, in that we were still using or having externally sponsored team-based projects, all of which had some aspect that was hardware-based. What's interesting about this year is that we had many class meetings. We only met once in person for the entire year. And that was the last day of class. And even so, we still had 2 people remote for that last class. Some of the logistics of what we did this year is that we flipped the classroom in that we recorded many videos, had related homework to those videos. We had many online presentations and expectations for peer feedback, which I'll get into a little bit more soon. And then we also had virtual design review panels where we had clients as well as other faculty members listening in on presentations from students. And then lastly, we had very frequent advisor and client meetings, meaning the students would meet with their professors as well as their external clients from corporations, all of which was over Zoom. I would like to make a plug here in that we have all these videos and we have all this framework available, and we'd be happy to share it with anybody who would like to see more of it. Happy to share the videos as well as all of the assignments that we put together. And lastly, some of the technology that we used. we used our meetings over Zoom. Much of our communication was over Slack, which is a messaging platform. Some students chose to use more other texting platforms. We're a Google Drive school. I understand that other schools use different types of collaborative environments, cloud-based collaborative environments. But these are our three main tools that we used in our course, and I would say that largely that we used these types of tools throughout the academic year. So all that said, we ran capstone design in a very strange way. It worked somehow, but I had to give two axioms. The first one is this: with the right technology, the right course setup, the right projects, even perhaps the right objectives, you can still have dysfunctional teams. So even with all the right technology and all the right setup, it's entirely possible that your teams can totally implode. So axiom one. And axiom two is that a global pandemic has a tendency to complicate everything. So everything that you do in terms of your best planning can completely fall apart due to the pandemic. So today's goal as we move forward is that I want to provide for you a framework to build team culture, along with giving you some practical tips as to how we implemented things this year, both in remote and non-remote context. I feel like as I'm giving my presentation today, that I myself, as well as perhaps other instructors at Bucknell, as well as other places around the country, we're emerging from the foxhole of COVID-19 in that we prepared a lot in the summer of 2020, going into the academic year 2021, knowing that we would have a very hard time. I feel like we tried a lot of different things in that this past academic year was almost like a living experiment from which we've emerged with some lessons. And at the same time, I have to give much credit to my co-instructors. You'll hear later on from Margot Vigent. She talks about remote labs. We taught together this year, and I'm so thankful to have Margot as well as Keith Buffington, who you'll hear from later today too, to bounce ideas off of, to learn from. And much credit given to my students as well for making it through a very difficult year. I would say that we tried lots of different things, some of which I'll share today. But what I'm going to be talking today about is a synthesis of all those things. You're going to see very shortly that a lot of what I'm talking about today is actually based on a book. And we'll talk about the book in just a moment. I read the book probably about a year and a half ago, forgot about that book. We tried all these things during COVID. And then I reread the book actually a few weeks ago, and I realized I think I learned a lot from that book. The power in perhaps framing it in terms of some of the topics in that book is that it makes a lot of the things that were implicit this year in our planning and makes it explicit. And I think there's a certain power to that. So without further ado, what we're going to be doing today is we'll talk about educational objectives, namely educational objectives about teamwork. And where that's going to lead us to is a discussion about culture. In our very short time together, I'm hoping to provide a framework of how to build culture within teams. And then to finish off our presentation, I've invited two people to share about what remote teams looks like in action. One of them is a student who just graduated from our program. His name is Liam Pierce. And the second person is my colleague, Professor Keith Buffington, who helped to advise two different teams within our course. So we may be familiar with this objective, this educational objective from ABET. I'll read it for us. It says that our students should graduate with an ability to function effectively on a team whose members together provide leadership, create a collaborative and inclusive environment, establish goals, plan tasks, and meet objectives. We actually use this ABET student objective as an explicit goal within our course, largely because it encapsulates a lot of what we do in this course. And I want us to join in together. So this is going to be an activity. These questions that are in this box, I want us to go into the question and answer right now. I know this may be maybe not the most common practice for you, but I want you to be a little bit more active here. Get onto your computers, type in a few questions, humor me here. So what is different in a remote or hybrid context when we're talking about teams? As you can imagine, your academic year coming up and the possibility of having to be remote at some point or having to be hybrid at some point, how do you imagine things would be different within these objectives? Which of these do you think would be the hardest to achieve? Maybe it's leadership, maybe it's creating a collaborative and inclusive environment. So go ahead and join in with me on the question and answer. And I'm going to try to move my screen around. I'm going to give you just 30 seconds right now as I figure out how to see. I actually can't see the question and answer. I have to figure this out.
I can do it.
Okay. How do I do this? I need 3 screens, in fact. I'm afraid of ending my slideshow right now. Oh no. Oh, sorry. So Ikoyan, can you tell me if there are any questions on the question and answers?
Not yet, because I'm also a panelist. I'm not allowed to ask questions.
Okay.
No questions. So
Okay, so I want us to pause right now, take a deep breath. I know that it is, well, here it's 8:10 in the morning, which means that it's 8:10 in the evening. Some of you may be in the middle of eating dinner or otherwise grabbing coffee or something like that. I want to invite you to try to use this as best as you can, the question and answer. And maybe we'll take a buy on this one, but there will be more questions and answers both in my presentation as well as in Professor Bijan's presentation upcoming. So let's go ahead and get in the habit of putting things into the question and answer, and we'll move on to the next part of this just for the sake of time. So moving on here, as you're thinking about how in the world do you build teams? How do you build an inclusive and environment? How do you provide leadership? I want us to break down this objective in this way. So this first part of the ability to function effectively on a team whose members together provide leadership, create a collaborative and inclusive environment, I want to encapsulate that in this word culture. And we'll talk a little bit more about what we mean by culture. The second part of the objective about establishing goals, planning tasks, and meeting objectives, I'm going to go ahead and put that in the category of project management. And for those of us who were with us about 1.5 years ago in Kaohsiung, we talked about project management and specifically about Scrum and teams. I'm not going to be speaking today specifically about project management, but I'm going to ask you to go back to the slides from that workshop. But instead, we'll focus and hone in on this idea of culture and how do you build culture within a team, and how do you build culture within a team online in a remote or hybrid context. So here's another question for you. And even if it is within the chat for some of our panelists and certainly for our participants, I want you to think of examples where teams have not produced work even to the sum of its parts, meaning this, that you have, let's say, 4 people on a team, you put all of their efforts together and somehow it only equals 3 people, or maybe 2 people, or maybe just 1 person. Have you ever experienced that? And I'm assuming that there are going to be a bunch of nods right now, where you can think of teams where you've had perhaps 4 people and somehow the sum of all their work didn't equal 4 people. So the question really here is, what do you attribute that to? And how would this be worse or better in a remote setting? So again, the question is this, that if you have a project team of, let's say, 4 or 5 students, your assumption is that, well, I should have the work product equal to the sum of those students. But many times you find that the work product that you get from 5 students or 4 students is actually only equal to 2 students. Why is that? And how would this be worse or better in a remote setting? So again, let's start to think about these things even while I'm talking. and put them into the comments, into the question and answer, or to the chat. And start to make some mental notes for yourself at the same time as I speak. So as you're thinking about this question, what do I mean by team culture? Right? And there are many different constructions of this. If you were to search the internet for team culture, or if you look for team or for culture separately, but I've created my own definition here. Perhaps it's faulty, and I'm sure that it is. But I encapsulate culture in terms of the interactions between the members and how those interactions impact attitudes, habits, and practice. And as you mull through and think about what this might mean, it means that you might have 4 people on a team, and the way that they interface with one another, the way that they communicate with one another, the way that they interact with one another will definitely impact how they do their work, what habits they produce, and what attitudes they have as a team. The thing is that as engineers, we tend to focus on individual contributions. We think if we have team member A, B, C, D, that we'll look at what team member A has done, and then B, then C, then D, and say, well, actually, those should all sum together to give us something that's the sum of A plus B plus C plus D. But what I want to tell you today, what I want to propose to you today, is that perhaps the culture, the interfaces between A, B, C, and D are actually even more important than the individual competence of each of those members. So think about that. We often think that if we have 4 superstars, or we have 2 superstars plus 2 slackers, or whatever it may be, that's really going to determine the function of a team or the success of a team. But what I'm proposing today is that the culture between A, B, C, and D is really what will drive the performance of a team. So that said, a lot of what I'm going to be talking about today is based on a book called The Culture Code by Daniel Coyle. I highly recommend reading the book if you are all interested in culture or in teams. There are many examples of sports as well as many successful cultures and successful teams. But what Daniel Coyle talks about in the book is 3 major things that make effective culture, that make effective teams. One of them is that you need to build safety. Second is that you need to have shared vulnerability. And the third is that you need to establish purpose. We'll be focusing on 2 things today, on building safety and sharing vulnerabilities. And as you think about these things, I have to confess that these are not normally things that we see in engineering courses. We normally don't see the objective of let's build safety together or let's share our vulnerabilities. And you may be asking yourself, number 1, why is that important? And number 2, well, how do we do that? And what I'm going to try to do today is to give you both. What do we mean by building safety, and how do we do it? And how do we do it in particular in an online or remote context? And number 2, what is shared vulnerability about? Why is it important? And how do we build that even in a remote or a hybrid context? To give a little bit of the punchline before we even get started, our role as faculty members, I think, is at least in 2 things. First is in modeling through action, in the way that we share our vulnerabilities, in the way that we build safety from where we're coming from, and the words that we use, and the way that we listen, and the way that we communicate. And the second way is by helping to build structures. What I'm hoping to be able to communicate today is that building safety and sharing vulnerability is not simply about being warm and fuzzy, but there are many specific things that we can do to do those 2 things. So let's move on. Building safety and belonging. I actually grabbed a quote from the book, and it says this. It says that group performance depends on behavior that communicates one powerful overarching idea. We are safe and connected. The idea here being that you can have, again, a group of A, B, C, and D, but their performance together as a group will not be the sum of those parts, or even close to the sum of those parts, if the members do not feel safe and connected. So with that, how do we do that? How do we build safety and belonging within a team or within a group? And I'll give you 2 things. The first thing is that it's important, it's critical, I would say, to optimize face-to-face time and leave room for banter. What I mean by this is this. You may be very limited in the amount of real face-to-face time that you have with your students. I mentioned before that our class met one time fully in person. But we had many small interactions where we would meet face-to-face with our student teams. Some of our students were actually remote for the entire year. We'll hear from one of those today. And the reason that this is important is that those face-to-face interactions or those one-on-one interactions will help to develop a relationship wherein you can build safety and belonging. In the book, it talks about creating safe, collision-rich spaces. I've put some of the quotes in the book in orange over here. And that sounds nearly impossible, right? It sounds nearly impossible to do in a remote or a hybrid context. But I've given some examples of how you might do this in that type of environment. First is and actually I'll go to the second one, is make best use of in-person classes, meaning that if you do have the opportunity, maybe it's at the beginning of the year or the middle of the year, or maybe it's in smaller groups, make best use of those times. I mentioned before that we used a flipped classroom this past year. We had a lot of videos, and then we had assignments that students would do, and then we would meet in person or virtually to talk about those videos. If you can move a lot of your normal class lecture time to a video and leverage those times where you're in person or in smaller groups together, try to do that. I mentioned before that we'd be happy to share the videos that we created for our capstone class with you. That might be a starting point for you. The other thing, and I found this to be very interesting, is to leave space in online meetings for offline chatter. This is probably a really confusing statement. As I mentioned before, I taught with Professor Buffington, who you'll hear from later, who's on the screen right now, with Professor Vigent. And a lot of times we would start our class a little bit early, meaning that we would get online a little bit early, let's say 10 minutes before, and we would just be talking about my son and Professor Vigent's son play soccer together. And we'd just be talking about the game. And what would invariably happen is we'd be talking about the game, and then a student would join into the class. And they would hear all about our sons playing soccer, or we would be talking about something else. And that had nothing to do with class. It had nothing to do with capstone design or the topic of the day, but that they heard us bantering together was super important. And it gave them space also to interject into that conversation too. Leaving space for those types of interjections are very, very important. So whether it be at the beginning of the class, in the middle of the class, or at the end of class, where you leave space for your students to listen in and to talk, crazy, and makes it such a huge difference. The other thing I would say is this, the big topic is establish norms on both desirable as well as undesirable behaviors. In the book, he talks about naming bad behaviors early, meaning that as you form teams, let's talk about what things are simply not acceptable. What are things that you don't want to do or things that you do want to do? One question for something that's online is what does it mean to be on time for a Zoom call? What does it mean to be on time for a video conference or a webinar? Does that mean that you're going to be 10 minutes early, 5 minutes early, 5 seconds early, or 5 minutes late? The problem with Zoom meetings and perhaps Microsoft Teams or whatever platform you're using is that the travel time from place to place, and I'm stealing this from Professor Vigent, is that the travel time is like 0 nanoseconds, meaning that you could finish a meeting and then have another meeting just like that, just right out, and it leaves no space for you to take a deep breath. Whereas in the past, you would walk from one building to the next, or even one office to the next, or one classroom to the next, and it gives you time to reflect on that last meeting and prepare for the next one. Leave space more than 0 seconds between meetings. The other thing is to consider what are cultural taboos that you're going to stay away from, or maybe they talk about just about in a private environment. Something that we ran into this year is that oftentimes we would see our students in a different background in their Zoom rooms. And that different background would be our COVID hotel. A lot of times our students would end up in quarantine, whether voluntarily or because they had contracted COVID. Is that something that you want to talk about? Is that something that's okay? I know that the culture in Taiwan is different than the culture in Lewisburg, Pennsylvania. Establishing what those cultural taboos are early and having that discussion is super important. There are more other things that I would love to talk to you on. I'm looking at time and I'm running out of time already. But one thing I do want to mention is the second point here within establishing norms. And it is, what does it mean to be an active participant in an online meeting? I'm going to let that one sink in. And I say it again. What does it mean to be an active participant in an online meeting? I had a very interesting experience a few weeks ago, and this was actually in an in-person meeting. I was in a very large meeting where I was in the audience and there was a speaker. So probably about 200 people, and there was a speaker. The speaker came up to me afterwards and said, "You're such a good listener." I had no idea what the person meant, but somehow they knew that I was actively listening because of my nods, because of my eye contact with that person. That's really hard to do online. Really hard to do. But what can you do? You can remain engaged in that conversation. You can add to the question and answer or to the chat. Something that we found in our class was that the more that people added to the chat within our Zoom calls or whatever platform it was, the more rich that conversation became, because we could draw from that chat. And I would encourage you to think about what that means for your classrooms and establishing norms for your classrooms as well as teams in letting the chat be something that lives in a really loud way, if you will. The other thing to be very sensitive to is there an expectation that cameras will be on, that people will be muted or unmuted? Right now, I can tell you right now that I feel very alone because I can't hear anybody else, but I know I see nods. So I'm glad that I see the other panelists nodding along. But establishing those norms, knowing that sometimes if people are zooming in from home or calling in from home, they might not have strong internet access. They might have a different home environment, and it may not be fair for them to have those cameras on. Establishing those norms and talking about those things makes a huge difference. And the last thing I would say in terms of establishing norms is making it a practice, asking the question of, have we heard from everyone? Have we heard from X, Y, and Z, A, B, C, and D? Because it's hard to interject sometimes online, harder than I would say in person. So something to think about, and I know that we're running out of time here, is what other ideas do you have to build safety and belonging in your context? I've given you our context here and how we did that at Bucknell, but how will you build safety and belonging so that people on online meetings, online teams will feel like they actually belong on a team, so that they feel safe, so that they can contribute. But I want to remind you, the reason that we do this is that when people feel safe, when they feel connected, they feel like they're part of the team. They feel like they're part of the group. Their performance together will then be greater than the sum of their parts. Then that's why it's important. The second thing I want to talk about today is this idea of shared vulnerability. The quote from the book says this: "Exchanges of vulnerability, which we tend to avoid, are the pathway through which trusting cooperation is built." So before, we were talking about belonging and safety. That's kind of the baseline to make sure that people are willing and wanting to participate. But exchanges of vulnerability is where you start to build trusting cooperation, where you have practices of saying, you know what, I screwed up, I made a mistake. And somebody says, same, I did the same thing. And they're then able to move forward and to learn from those practices. Bear in mind that the word here is shared vulnerability, not share vulnerably. That doesn't mean that you're not sharing vulnerably, but it means that you're sharing in risk. You're sharing in your vulnerabilities together and acknowledging that we all have weaknesses in some way. This is probably the most confusing thing that I'll talk about today, so I want to make it real. So let's talk about what this might look like. So the first thing, and I can't emphasize this more, and I know that this is probably a cultural taboo, I know it is for me, is that we need to follow the leader in this. We as faculty members need to show our vulnerabilities. We need to be able to say, yes, we make mistakes along the same way. Let me give an example of this. I had a student during a Zoom meeting who was sharing screen, and I'm sure that this is starting to sound familiar, who was sharing screen on the Zoom meeting, and then all of a sudden checked her email while sharing her screen. And I'm kind of chuckling a little bit, not because I think it's silly that she did it, but because I did the same thing 2 weeks beforehand. So I didn't call it out at that moment, but what I did is I asked to have a meeting with that person a few days afterwards. And I said to this person, I just wanted to let you know, we saw that you shared your email, and this was with a meeting with a client. So an external client saw her email as well. And I had to share with her, I want to let you know that this happened. It was perhaps not as professional as you hoped it would be, that meeting, but I did the same thing. I did the same thing 2 weeks ago in a faculty meeting where I was leading the meeting and I checked my email while somebody else was talking. It happens. What did this allow us to do? It allowed her to see that, I'm fallible as well. But it also gave her the courage to really say, yes, I made a mistake and I'm not going to do it again. And it gave us a pathway to continue to cooperate together. The second thing I would say in terms of sharing vulnerabilities is that it's important to over-communicate expectations. That's something that's from the book as well. And what I mean by this is that your expectations on cooperation, especially during remote and hybrid teams, has to be very, very explicit and has to be repeated. Asking questions like, what challenges or opportunities are presented due to remote learning? And we'll hear a little bit more about this from Liam as he shares in just a moment, is very important. So if somebody's stuck in a hotel room or somebody is stuck at home, what can they contribute compared to somebody who's on campus? And being very honest and open with that. The other thing I would say in terms of being the instructor are, what are the expectations that the students can have in asking for help, and how do you respond to that? Let's say that somebody has contracted COVID, or one of their family members has contracted COVID, or something else has happened. What we learned this year is that empathy and flexibility go a very long way with our students. It may seem like we're being soft, or it may seem like maybe the objective isn't being met, but we have to realize that our students are people. And in recognizing that they're going through a lot of things, just like we're going through lots of things, is number one, a recognition of our humanity, but number two, it helps in their learning too as team members. And the last thing that I'm going to say, and I'm going to switch things over to talking to Liam and Professor Buffington, is using what we'll refer to as after-action reviews, meaning this, that you go through an experience, let's say that you're working on a part of the project for 2 weeks, and having a moment where you can review, asking questions like, what were the intended results? What were our actual results? What caused those results? What will we do the next time? What will we do differently? This one isn't isolated to remote or hybrid teams. This is something that you should do on a regular basis anyway. But this type of action, this type of conversation that you have is something that builds on vulnerability, meaning that we recognize mistakes that we've made. We acknowledge that we have made the same mistakes. Let's say that team member A says, yes, I should have done this differently. And team member B acknowledges, yes, I should have done this differently. And we'll move forward together. In this very brief time, I've talked about trying to dig into sharing vulnerabilities in building cooperative work, in building cooperative teams. But I think that perhaps this will become a little bit more real as we hear from one of our students, and as we hear from one of our faculty members, as they talk about some of these principles and some other practices. So I'm going to wrap up what I'm talking about here. Remember, we started with this axiom that the right technology, core setup, projects, and objectives can still result in dysfunctional teams. What I've tried to tell you in the last 25, 30 minutes is that perhaps we can address part of this, at least, is by focusing on building culture. But building culture is not necessarily a very nebulous thing. There are specific actions that we can take by building safety and belonging, by establishing norms, by optimizing face-to-face interactions, and by sharing vulnerabilities through setting expectations on cooperation and having candid reflection. In this very brief time, I know that I've glossed over a lot of different things. I'm happy to address questions a little bit later on, but I'm eager to move on to the next part of our presentation, which is to hear from two people whom I respect very deeply after having gone through this in the trenches for the last year, where they're going to be talking about what their teams look like during this pandemic. So I want to invite Liam Pierce to share from his perspectives. And Liam is a graduate in mechanical engineering from this past year and is joining us from home.
Okay, hello everybody. As Professor Kim said, my name is Liam Pierce, and today I'll be talking about my experience as an engineering student in this remote learning environment. So as a quick introduction to myself, I'm a recent graduate of Bucknell University, as Professor said, with a major in mechanical engineering and a minor in physics. Over the course of my Bucknell experience, I developed myself as a problem solver, as an effective organizer, and as someone who can step into a leadership role in order to kind of outline and plan long and short-term goals within a project. Specifically with this presentation, I would like to touch on my senior year at Bucknell, where I studied remotely while taking an engineering course called Interdisciplinary Senior Design, which was taught by Professor Kim, Professor Buffington, and Professor Regent on this call. So in this course, three of my teammates and I worked to develop a method and working prototype of a system to generate a simulated nitro cold brew style coffee for a single serve pod-based brewer. And this was in collaboration with the Keurig team. And on my team, there were two mechanical engineers, a computer engineer, and an electrical engineer. For the first semester of the school year, I was the only remote student on the team. But for the second semester of the year, both myself and the computer engineer were studying remotely. And as for the two students on campus, they experienced long periods of strict COVID lockdowns where students were unable to meet in person or go to any labs to work. And at one point in time, one team member even did test positive, and both of them were forced to quarantine. Despite all of this, our team used the following tactics I'll cover in this presentation to not only make it through the year, but excel in our project goals. So throughout the year, the largest contributor to my team's success was our ability to communicate effectively. At all times, we as a team were able to get relatively immediate feedback from not only each other, but from our liaisons and advisors. As the year progressed, we were able to spend less and less time in meetings and more time working effectively on team goals. With remote learning, communication is not always straightforward, as when everyone is in person, teams have to determine what system is the easiest for them. Because in a difficult situation like remote engineering, the more efficiently your team can communicate, the more time you'll be able to focus on your project work. As an example, most groups within our course chose to communicate through Slack messages, which is a form of group chat. But what we experienced early on is that although Slack's filing mechanism for their group chats made it favorable for class announcements and organization, it often caused delays in messaging and slowed down our team's overall communication capabilities. So instead of relying on Slack, we had to pivot and develop a new method where we would meet at least for 5 minutes each day on Zoom to kind of share progress, updates, and quickly plan expectations for the week. And if there were any intermittent questions or updates from a member, they could be quickly sent through text in a group chat so everyone could be on the same page instantaneously. Breaking up the week into individual and team sessions allowed for everyone to accomplish tasks while ensuring that we all had the same expectations for the end of the week. My main point being that as teachers and guides for these students, it'll be important for you all to highlight that simple methods will likely prevail in difficult circumstances, and developing clear-cut methods for communicating, as well as structured schedules for the short and long-term goals, will pay off significantly over the course of the project. The ease of communication within the group will also allow for a team to build stronger sense of identity and will enable students to rely on each other, especially in the face of adversity. So moving on to the team culture and collaboration. When working with any team, it is important to establish the strengths and weaknesses of each member early on. Especially with remote learning, it is critical for members to be able to play to their strengths. As a mechanical engineer, I was very used to working hands-on with materials in the lab. But as a remote student, I was forced to take a step back and consider how I could best help my team from where I was. I was able to shift my energy to focus on the team's organization and planning, which allowed other members who had the access to the lab the opportunity to conduct necessary tests on our project. And as a very visual person, I was also able to develop thorough designs and graphics that my team members could kind of use as blueprints throughout the project. Students may struggle to find how they can positively contribute to their teams in this environment. So encouraging these conversations early on will allow them to isolate their skills and develop them throughout the year. This applies to troubleshooting as well. With remote learning and engineering courses, the ability to remain flexible and creative is critical. This year, my team faced many challenges that were both expected and unexpected, but in order to overcome these obstacles, everyone on the team had to remain agile. Many times during this year, our team had to come together and ask ourselves, is this the best way we can be doing this? And how can we be doing better? Do we need to be changing our objectives or our weekly schedule? And most importantly, are we using our resources and technology properly? As I mentioned earlier, I became largely responsible for generating all of my team's designs, graphics, and tables. And as a result, we had to find the most effective way for me to get my drawings to the rest of the team. Rather than spending an excessive amount of time drawing with paper and pencils and sending it to my team over text and then having to redraw it if there were any issues or changes, I focused on developing a method where I could make rigid but effective drawings on Google Slides so that they could be shared with the rest of the team instantaneously. This way, if any changes were necessary, they could be made straight from the initial drawing without having to go back and redo everything. Encouraging students to use the technology and resources available to them will not only improve their engineering capabilities remotely, but it will force them to recognize how they can positively impact the team in ways that they may not have originally thought about. As students open up a dialogue about their skill set within the team, they'll begin to recognize the value that each member can bring to the project. And now I am happy to pass it over to the person who was my project advisor this year, Professor Buffington.
Thank you, Liam. Yes, my name is Keith Buffington. I'm also at Bucknell University, as Charles Kim was saying, Professor Kim. And I have the opportunity now to talk about some of my experiences as a project advisor. As Liam was just saying, I was the advisor for his project working with Keurig Dr. Pepper. I was also the advisor for another team working with the company JLG. And I would say as an advisor, I tried to approach both of these project teams similarly, but I think the outcomes were different. So it provided me with a great opportunity to think about what was working well and what was not working so well. Some of it had to do with the individuals on the team, of course, and the way they interacted, some of their backgrounds, but some of it, there were broader issues as well. So just to build on what Professor Kim and Liam were talking about, I think for me, the most important parts in advising the teams and getting them to work together effectively, communication was huge, clarity of expectations in all fronts in ways, and clarity is always part of what we're trying to do with our teams and in our courses, but in a distance learning environment or a hybrid learning environment during a pandemic, of course, it's even more important. And structure, I think that was another big part. You know, there were certainly many difficulties that we encountered. I'm really going to focus on a few of them, but the course taught in this environment as hybrid and during the pandemic provided us with new opportunities. It provided us with the opportunity to rethink what we typically do. You know, I think there's too much of a tendency for us as instructors to fall into ruts. We do things that worked in the past because they worked in the past. But when you're faced with a new situation, you obviously need to rethink that. And sometimes you come up with better results. Professor Kim talked about flipping the classroom and pre-recording lectures. That worked, I think, extremely well for our course overall. The other thing that was important and was emphasized in this environment, we've always interacted with our clients largely remotely. I think we gained greater empathy among ourselves and among our students with interacting with our clients because they had to interact that way with each other. But to build on some of those comments, there are certain things that I would like to emphasize and pass along to you that I think can be helpful. You know, what were some of the particular challenges of promoting good communication among teammates during a pandemic? You know, it was difficult right from the beginning. We've always tried to promote good teamwork, of course, within our teams in the course. But usually we do that through icebreaking activities and team building activities, which work really well in person, but don't work so well online. So I think we really had to rethink how to do those things. And we still needed that team bonding. We needed that vulnerability, as Professor Kim was talking about, but it was much more difficult to create online. So we had to work through that process. The other thing that Professor Kim mentioned is that there are so many more distractions when you're working online. If people are sitting in a Zoom environment or a WebEx environment or whatever environment, they're in their home, as I am here, or they're somewhere where they have access to lots of other things that they think about in their life. How do you filter those things out? How do you engage, as Professor Kim was talking about, and really being an active listener? And the other thing that I think was accentuated in the online pandemic environment, hybrid environment, was the fact that really our teams were not all the same. You know, our students came from a different background. They didn't necessarily speak the same language, technically or otherwise, and they were in different places, physically in different places, and they had different access to resources. So that was always a challenge. You know, I think some of the things that are very clear in the hybrid environment that are less clear when all the students are working together in the same place physically is not all students are going to contribute in the same way. Not all students have the opportunity to contribute in the same way. There has to be an open and direct recognition of that among the students and among the advisors, the faculty, the clients, so that you can start thinking about how can you better allocate the resources that students have? What can they do when they're working from home? Who does what in the lab? That was very important for Liam's team. They were very good about recognizing who could do what and making sure that the people who had access to the resources physically on campus were willing to take on those roles. The relationships, of course, are different. You know, that is a big part. That just recognizing that, you can't go into the expectation, you can't go into the team and the teamwork in a hybrid environment thinking, yeah, this is going to work kind of the way things have worked in the past. It's different, and you have to recognize that the relationships are different. And I think for me, and I think Professor Kim was alluding to this as well, is that as a person who's trying to lead the teams, the feedback that you get is different. As an instructor, I'm a person who likes to read the room. I like to look in a physical environment. I like to look around the room. I like to see who's paying attention. I like to see who has questions. And that's pretty easy to do in a physical environment and much, much harder to do in a hybrid and team environment. One of the things that was really paramount to me in the two teams that I worked with is the question of what made one team work better than the other. You know, as Liam talked about, his team was very structured. They committed to the structure and they were willing to do whatever it took to make progress on the project. I think that was an expectation that they established for themselves early on. And I think my other team was not as good as that. And I, as an instructor, was probably not as aware as the importance of that. I think if I had led them better, if I had engaged them sooner, earlier, differently, I think I could have helped them build the structure that they were committed to that would have worked better. I think they faltered in some areas. Dealing with problems is more difficult. Professor Kim was talking about taking students offline and talking one-on-one. I did that a lot, not with Liam's team, but with the other team. Talking individually with students on the team about some of the things that they were doing on the screen, which were distractions to their client and to the other teammates, and were distractions for them. And some of the challenges that they were having, you know, whether they were feeling engaged or not, whether they were able to step up. The other thing I did a lot, and I do this in person as well, is really ask direct questions. You have a team of 5 or 4 students, maybe with a client sometimes. You can ask them directly when they don't seem to be contributing to a conversation. That's kind of a basic 101 teamwork kind of thing. But I think in the online environment, the hybrid environment, you have to emphasize that. You have to say, Liam, what do you think about what Ethan just said? You have to be very direct about that. So you make sure that everybody contributes to the conversation. And kind of wrapping up, I know we're running over time. For me, the real big takeaways was really to rethink everything. Don't fall into the ruts that you might have fallen into with teaching in person, even if you've been extremely successful over the years. Hybrid pandemic teaching, it's different. Structure was huge, commitment to the structure, and then really an accountability to following through was hugely important. You have to reach out individually sometimes to make that happen. But I think if you work closely with your with your students and with your clients and with the other advisors that can happen. And communication is key. You have to just keep in communication with everybody in whatever way, as Liam was saying, whatever way makes that best possible.
All right, thank you so much, Liam and Professor Buffington. I think you really brought to bear a lot of things that we spoke about earlier in the workshop, as well as bringing some other great nuances of how this practically worked out on some teams this past year. Thank you for your vulnerability. I feel like I've grown in my own cooperative and desire to cooperate with both of you, even through this time. As we wrap up today, I just want to remind us of what our goal was today. I wanted to provide a framework to build team culture along with some practical tips how you implement this in both remote and non-remote contexts. I know that we really went very, very quickly today, and I want to open up the opportunity if anyone wants to contact any one of us, but myself in particular, with some more details or coaching or whatever that may be. It's been a pleasure to speak with you about what our experience was like this year and some of the lessons that we learned. And I'm going to pass this off now, and I'll stop sharing screen. Thank you.
Thank you, Professor Kim, Professor Buffington, and Mr. Pierce. Thank you very much. Okay. Our next and the final speaker is Professor Margot Vigen. Her topic is Laboratories when students can access the lab. I think this is supposed to be very interesting. Please welcome Professor Vigen. Thank you.
Professor Chang and Professor Yang. I am thrilled to be here, and I find the order in which we are going to build very nicely when we are talking about, here we go, sorry, I was not using the full screen. When we are talking about curriculum with Professor Wellerman, we get the big picture, and then how are we going to enact the new engineering education method, experiment, and construction, this undertaking that you're all engaged in to bring project-based learning throughout your curriculum. Teams are critical for that. And then many of you, I know, are relying upon hands-on work with the students to get this done. And at the moment, as you just heard from Liam and my colleagues, we just went through a year where sometimes the students could be in lab, sometimes they couldn't, sometimes some of the students could be in lab and others could not. And we recognize that you are facing perhaps a similar situation. So I want to help you think through, how do we do laboratories, and what I mean by that is anything hands-on, projects as well, when students cannot always access the lab. And again, I want this to be somewhat active, but I do see, as Professor Kim pointed out, that I can't see the chat. So we'll just roll with this. So I have 3 parts to this. The first 2 are all me, and then we'll go into the Q&A. So 1, I want us to focus on what laboratories are useful for. What are we trying to achieve when students do a hands-on project? And then once we know what we are trying to achieve, we can look at the methods for achieving it. I also want to mention, I asked that my slides be shared with you all as a file ahead of time. While I'm going to ask you some questions and ask you not to look ahead to give me answers, I do want you to have that file available, because when you are working on your own project or lab, it will be helpful to see the text. So if you have access to that file, please go ahead and open it. Okay, so we've inferred, and our project, Professor Kim and I spoke last time in January about active learning and how to involve students in their own learning to move past pure lecture. And this has somewhat hurt us coming into COVID, because if all we needed to do was lecture, there is a straightforward way to do that. However, we make a video. But now that we want students to be active and engaged, we find ourselves what I would call the laboratory zone in an active classroom, in a learner-led classroom. And it is a bit more challenging to keep that enacted when some or all of our students are studying remotely. So let's think about this. Let's reflect. What is the point of a hands-on lab? And also, you might include in your thinking when you do a very small experiment or a demonstration for students. All of this is part of what I want you to reflect on. So I am going to call this an activity. If you have someone with you, you may discuss with them. But I would like you to think, what's your answer? What is laboratory, what is hands-on laboratory for students achieving? Then if you have someone to discuss it with, please discuss. But if not, you are both sides of that conversation. And then I would like you to share in the chat. So please give us some reasons to do lab, and I will turn to my colleagues and ask if there are things in the chat that we could talk about. Oh, here we go. Oh, neat, I could see it. I figured out how I can see the chat. I appreciate what you have said. I invite you to say some more. So I have seen people mention that the experience of lab is important, that practicing their skills is important, that the action of doing science or engineering, get the hands dirty, thank you, and to connect theory and practice is important. Thank you so much. And I also want to say thank you. I do recognize some names from when we visited last January. So it is very nice to see people again. So these are all, I agree, I endorse these ideas. And Professors Faisal and Rosa published a paper 15 years ago now, in which they developed 13 common objectives that are achieved by engineering laboratories. And I refer to this paper quite a lot. So you'll see this citation again. But you see many of the things that you brought forward are also here. So in brief, what do we want to achieve in laboratory? We want to give students the opportunity to select instrumentation. What is the appropriate tool for this job? We want them to get their hands dirty and compare theory and practice and validate theory. We want them to have designed an experiment. So what is the most elegant way to use your laboratory time? We want students to practice data analysis. We want students to actually build something. So design it and then put it together. What are we making in this entire system or a part of a system? I think all of the, anyone who has been a graduate student realizes that a significant part of laboratory experience is learning from failure. When you try to make something and it just does not work the first time, and then you realize you need to check for continuity in your circuit, for example. We want students to express creativity. Psychomotor skills means that there is actual skill to running many of these processes, right? We could read about using a mill, but it is not the same thing as actually putting your hands on it and machining a part. Finally, there's some other opportunities we have in the laboratory where we ask students to identify and mitigate dangerous aspects of their experiment. We ask students to communicate what they learned or what they intend to learn as they are walking into lab. Laboratories are almost always an opportunity to practice teamwork because very seldom do we have enough space that each student is only working on their own project? Students' ethics are certainly tested by being in a laboratory, doing their own work as opposed to using someone else's. And an underappreciated element of being in a laboratory is sensory awareness. So what we mean there is if a pump is not working properly, that is something you can hear. It's something you can see, but it's not something you would necessarily know just by having solved an equation about fluid mechanics. So this captures pretty well what you all said and what others have said about laboratories. So I want to ask one more chat question at this point. And this will be a place where it is helpful to refer to the file, because then you can see what those 13 objectives are. I'm going to ask 3 questions, but the middle one is actually, the top 2 are the most important questions. So first, what do you feel of that list of objectives is the most important? What is the most critical thing for students to derive from hands-on processes? Please go ahead and put that in the chat. And I know it can be hard to just pick one. Oh, can we see the previous slide? Sure. I can move to the previous slide. Oh, there we go. Previous slide. So what do we think of these as the most important? Okay. So we have some feedback. Learn from failure is certainly critical and possibly unavailable to other parts of our educational system. If you are solving a problem with your calculator, you might not know you have failed. And then implementation, where we said before, getting your hands dirty. You can't really do that any other way. And actually practicing, seeing that theory is truly something that describes the world. You can't just do that with theory. So thank you. I'm going to ask one more question, and I'll come back to this slide. Of these, my pleasure. Of these objectives, what is impossible for remote study? So I'm going to back up. So of these 13, all these 13 are possible in our university laboratories. What of these can't we do at all if students are in their homes or in an isolation unit? So, and again, you can please put that in the chat. So yes, so some things that are difficult, sensory awareness, very hard to hear the pump when you are far away. Implementation, also quite challenging, especially for those disciplines that need specialized equipment. Design and assembly, and some people are nominating teamwork, although I'm going to suggest we rely upon Professor Kim's talk that doing the teamwork is impossible. Is possible, that is, not impossible. But yes, implementation and communication is much harder. So here is my version of the list when I edited. So what is missing? I put in gray the elements that are much more difficult or perhaps impossible. Implementing the experimental design may not be possible to do remotely, but you could still design an experiment. Likewise, you could design a part or a system, but you probably cannot assemble it. In fact, Mr. Pierce gave that example. He was designing parts for his team, but it was up to them to use the 3D printer and actually implement them. Having students practice their actual skills of manipulating equipment and hearing what is happening with that equipment, that is also just about impossible remotely. But I want to say to you, we could do all the rest of this, which is not too bad. So all the rest of this is still possible. So we can get at most of what we want. I want to give you a few case studies of ways in which colleagues implemented remote or partially remote labs that hit several of these objectives. So for example, in Bucknell's own environmental laboratory, which is part of environmental engineering, they turned their laboratories into a combination of videos and data analysis. So of our objectives, the ones in bold are the ones that were hit very well, and the ones that are not in bold were partially completed, or completed, completed but not the primary goal. So what did the students do here? The students watched a video of Professor DeStefano completing the laboratory, and then they were given data as though they had used the equipment. And the students were asked to analyze the data and communicate what the result was and what their recommendation for the experiment would be. So this is an example of a way you can implement a remote laboratory. At the University of Connecticut in chemical engineering, some first-year students were asked to perform a hands-on project, but from home. And a part of this hands-on project was measuring pressure differences. So how they did this was they were charged to use things that they had in their home to assemble a part. So this was a terrific design exercise. You can see this is a manometer that has been constructed out of a cardboard tube, duct tape, and a plastic tube, and is being tested with a hairdryer. You can also see that this is clearly in someone's home. The reason it looks like it does is the student is using the doorknob of this door to balance the manometer. That's what the two black circles are. Yes, I agree. In this case, nothing was destroyed because this is a very, a mostly safe apparatus as long as you do not use hot air in the hairdryer. But you can see that this setup, every student did something different. So they all built a manometer, but they built them in different ways. They were very creative. They had much opportunity to learn from failure. And they designed or assembled the part. It wasn't the most complex part, but it was still a functional part. At Oregon State University, they have a simulation for chemical vapor deposition for the creation of computer chips. And in fact, this simulation predates COVID restrictions because the experiment itself is too expensive to have students do. So they have always used a simulation. And this does still allow a comparison of theory and practice to some extent. You need to trust that the simulation is truly enacting what would happen in an experiment. So that's a little challenge. But it does give students a significant opportunity to do experimental design and implementation, in part because the simulation limits the number of times you can run an experiment, just as would be the case in real life, right? You can't always spend $1,000 each experiment and run 50 experiments. So this simulation says, here is your budget. You may only spend this much money. And so students are pressured to optimize their use of the experimental apparatus, even though it is a simulation. And one final example for this part here, at the Rochester Institute of Technology, a colleague sent a control system, a basic control system, to each student. And then they, on their own, had to implement and troubleshoot that control system to achieve a task. And the students were given some freedom that while the system they were sent was optimized for doing the ball balanced on a beam, the students could reuse the motors and the Arduino to build a variety of control systems of their own choosing. And so the students used these motors and the computer and their own programming and built a variety of systems of interest to them. And so there was a lot of learning from failure and creativity, but in some contrast to the manometer example, we had a higher level of technical sophistication in the comparison of theory and practice and experimental design and implementation. This project was scaffolded and took most of the semester. So you know. Okay, hopefully you have become, so the process of, so a colleague has mentioned in the chat, acquiring data is missing. Acquiring data is not missing from this one. So here, because the students have the chip and have their computer, they are actually acquiring the control system data in addition to modeling the control system. So this is an example where both pieces happen. All right, I am going to be quiet for a bit, and I would like you to do some work. And you don't have to show this work in the chat, but I'd like you to get out a piece of paper or type on your computer. And for a project or a laboratory for your class that is upcoming, or that may be at some point in the future if you don't have one immediately, which of the 13 outcomes, so you will want to look at your handout, does this lab address right now? And what subset of those outcomes are you willing to say are the most important that you must design to achieve if your students are remote? So that is, select the most important 1, 2, or possibly 3 things that your remote lab must still achieve if you need to be working remotely. This rainbow on the screen is a timer. Each bar will disappear after 30 seconds. And we are going to wait this whole 3 minutes, which may seem like an eternity, for you to take the time to select the most important outcomes for at least one laboratory or project. Okay? And please review in my handout file to see the list of outcomes, because I won't be able to flip back while I have the timer up. All right, here we go. Technically, time is not up until the last little bits fall off the bottom. But yes, okay, so and I see some colleagues have shared their #1 outcome, creativity, analysis, and again, yes, additional creativity. I want us to focus on this as an opportunity. In fact, we can ask students to demonstrate more creativity when they are remote than sometimes when they are on campus and we must provide everything. But I do recognize we are going to lose some things. That's by focusing on select outcomes, we can ensure we will hit those outcomes and come to terms with the fact that we may not hit every single outcome that we used to. Very nice. So now that you have an outcome, let's go through some ways you might achieve that. So we looked at labs and demonstrations and projects can have specific outcomes. I know that quite often when we have some laboratory experiments that have gone on for a long time, people have never thought about the outcomes because it is tradition. But it is important to go back and look at the outcomes. And then by breaking our lab experiences into those constituent outcomes, we can work to address them in our new setting. So something that comes up quite often is the validation of theory. So I'm going to make sure I address that one in particular. But all of these things that are not in gray, we'll look at some examples of how to hit. I put a nice glowing arrow. Validation of theory. So here I've done a survey and I've talked to colleagues and I have kept up with the literature. This is the list of general ways in which we can incorporate some or all remote students in a laboratory setting. So the first thing that may seem clear to you is that if you can have some students on campus, then you have your laboratory or project as it has always been, but some of your students are brought in on each other's phones, for example. So we just do a live feed to the room and use that as a way to bring some students along. And I'll talk about each of these in turn, but I want to give you the overview and define it first. We can also have the students do the experiments or projects themselves in their own homes. We can have students do what I call work order. So that is, the students are far away, they can't access the equipment, but just as you might see in a workplace setting, an engineering workplace, the engineer doesn't do the experiment, they write up a detailed plan for the experiment and ask a technician to do it. And the technician reports back the data. And so that is a way, if only some people can access the lab, especially your teaching assistants, that is a way to have undergraduates get data that they have commissioned. An option that's slightly different from that, but in many ways similar, is what I showed from the environmental lab. You make a video of data being captured, and then you share that video and the data with the students. Two more options: simulation. So the experiment goes away entirely, and we replace it with a model of that experiment, a model that generates data. And then finally, we have what I call thought experiment, which is no video, no remote, no simulation. I just describe to you what the experiment would be, or I show you a picture of it, or a diagram, and then I give you some data for you to analyze, for you to consider. So this is a continuum, this is a menu, and what I'm going to do next is I'm going to do a little more detail on which objectives are achieved by each of these and why you might want to choose them or not. And then we'll have time at the end for you to consider, for the laboratory that you are working on, which method might be most appropriate for you. That helps you hit your objectives. So let's talk about the traditional hands-on lab that has some students on campus, some students off campus, but them working together. So this continues to hit the comparison of theory and practice, validation of theory, and it relies quite heavily on teamwork. And why do I say that? Because you will have some members of your experimental team on campus and some remote, probably. And why would we accept this? Why would we allow this to be our option? Well, if you think about many hands-on projects and experiments, not every student is touching and using every piece of equipment, right? If we need to measure the pH of a system, one person gets the sample, puts the probe in, reports the number to their teammates. So, and what can be nice about this approach is it is something that can be implemented at the last moment by the faculty. So here you are, we believe all classes will be in person, and then something happens, there is an outbreak, half the students must go home. And you have 1 day to prepare. You can make this work with 1 day to prepare. Here are some significant considerations. One, can you get a camera into the right places in your laboratory? Something that you might want to do is purchase some tripods with cell phone holders, because perhaps you can count on students to use phones to bring their classmates into the lab for you instead of using one big screen. Something else that is very important and challenging in a lab is sound. So if many of our laboratory spaces, I'm in a laboratory space right now, it has a speaker in the ceiling, but if I have a student remote and they are speaking and they're just coming through the speaker in the ceiling, we might not hear them because the laboratory is noisy. Something that can work for this is if you have students calling their classmate. So I am on a team with Liam. I use my phone to call Liam in a video call, and then I use my earbud so that he can hear me and I can hear him. And I repeat what the professor says for him, and when he asks a question, I relay it to everybody. That's a little cumbersome. Alternatively, the TA or the professor can be the person with the phone, the camera, and the earbuds. But it does mean you're speaking a little differently than you normally would in lab. You have to remember to repeat things for the person who's in your ear. But with practice, this is possible. And this is a thing many of us did all year. And then the final element is, can you help the students differentiate their roles on their team? So when Liam was presenting just now, he said he would do designs and then another teammate would physically implement them. So that was a really good collaboration. So for your team, whatever project it is they're working on, can you help the students define roles so that some students working remotely are doing experimental design, or perhaps more of the analysis, or perhaps more of the presentation, while the students who are in the room are doing more of the measuring pH. So these other options, I'm going to go through them in order of least difficult and expensive to most difficult and expensive. So, thought experiment. It does mean we are not we are giving no students hands-on options. We can still compare theory and practice, but here, really what we are doing as faculty is we are taking old data from a previous time the experiment was run and a photograph that we may happen to have, and we ask the students, here is the experimental setup. What do you anticipate will happen? Have them write a prediction. And then you provide them with data and have them analyze and compare their prediction to what really happened. This can be quick. This can be highly effective. But it does mean we have left off all of the skills practice. And in fact, I'm going to give you an example of this as an activity. So here is an experiment that normally we would have the students do. It is a fast, small experiment. I may have shown some of you this before. So we have 2 glasses of water. In 1 glass of water, we have 25 grams of ice in small parts. The other one, we have that 25 grams of ice as a large single ice cube. And it's supposed to be 100 mils of water, although actually in the picture, you can quite clearly see it's 200. So I just realized that I'm lying. But it is at 25 degrees C. And so here is your thought experiment. I'd like you to make a prediction. If you are feeling brave, you may write your prediction in the chat. Does which of these 2 cools more rapidly? And which of these 2 cools to a lower temperature? And if I was doing this in class, I'd bring out the timer again. I would make everybody write it down. I would make, if I was doing this in remote class, I would have a survey open where the students could anonymously respond, but I could grade them because I would know who they responded, but they wouldn't all see. Would anyone like to put forward an answer? Go on. Okay, thank you very much. And there is some pressure for writing into the chat, which is why I make it anonymous with students. And thank you. Okay, we have a few. I appreciate it. All right, so the chipped ice indeed cools faster. Here, I will show you some data. So here is the data for us to analyze. So the colors match up. So we had red was chipped ice and green was single ice cube. So here we have red, and you can see that the red temperature drops more rapidly. And you can also see that ultimately, because in either case it is 25 grams of ice, the ultimate temperature change ends up being the same when they are both fully melted. And so now we could write a report about this, or we could do a reflection. And so that is very inexpensive. It is fast. It relies upon you, the faculty member, for having some data and pictures that you can bring in to have the students talk through it. But it works. And I highly recommend doing it with both the prediction and a reflection. Because if we don't start with the prediction, students often skip that part of it. So simulation, a really good simulation. Now, simulations can be as sophisticated as having something graphical with interaction. But simulations, as you all know, can be a MATLAB file or a Excel file. So simulations don't always have to be pretty. But in the simulation, we have a good opportunity for data analysis and for testing experimental design. So those are the two objectives that hits the best. Something that you want to ask yourself about simulation is these can be time-consuming to write. So it is helpful if there's one that exists already that you could use. Or if you have someone who works with you who could code it before the semester starts. You can also hybridize this with video. So that is, you could have a video of a piece of equipment, and then the simulation provides the data. I will also note for many of the simulations that I am aware of, they have noise programmed into them to make it so that, as would happen in the actual experiment, you don't get pure theory with an R² of 1. So that's something to think about here. So here is an example, also from chemical engineering, of a reactions experiment. And that this is an excellent simulation that you can access for free online, if this happens to be your field. And it has some noise, you have to pay for the experiments, so you have to work. And also, it has some of the physical manipulation. So that is, to make this experiment work with your mouse, you must turn the valves at the right moment. And you also have to wait, just like you'd have to wait in the actual lab. These sorts of simulations take months to make, whereas you could do something with MATLAB much more quickly. Okay, moving on. Let's talk briefly about video. Video, again, lets you validate theory and analyze data. It does mean your entire class tends to be working with the same data. And so if you have ethical considerations about that, you might want to think about that there. And yes, I agree that for simulations, I would much rather use commercial simulations than one that I code. With video, you may also wish to use video that has been well lit and well edited, rather than what you might capture quickly with a phone. Okay, coming into our final two. Work order. Work order allows you to do some design and implementation. It requires that somebody still be able to go into the lab. In many cases, this is a graduate student, but if you are on a full lockdown, they might not have access to the lab either. But this is excellent training for how students will eventually work when they are practicing in industry. And you can have this be something that is live, where when the technician is enacting their job, they must be watching through the video and taking notes. So that engages them in the time and further observation. Or it could be purely they send a text document in and the TA sends them back exactly the results that they asked for. You need also buy-in from the TA for this, so that the TA does not fix errors that the students ask for. So if the students fail to say, set the temperature, the TA needs to not set the temperature, even if they know it will not be a good result. And last but not least, this is an exciting approach. I really like this approach. It's the one that lets us best design and assemble a part. It's also the one that lets us best learn from failure and experience creativity. That is, having the students do the work in their home. And this works better for some disciplines than for others. Our colleagues, the civil engineers, we might not be fracturing reinforced concrete in our homes. That's probably not okay. But you can do many circuits, many chemical engineering and mechanical engineering designs, and certainly computer science from home. So key questions: is it safe? Can you ship materials? So this becomes a lot better if, rather than assuming all students have certain materials at home, you can send them some of the materials. For example, some of my colleagues in Florida built small distillation columns and sent them to every student. The students had to program a control system for that distillation column, so they did have a lot of work to do, but the faculty and staff did work on the front end. And then my final guiding question here is it truly accessible or affordable? We should not assume all of our students have certain things. So for example, if we want the students to go out and do an experiment on a car's engine, we should probably not assume that that's an okay thing for everybody to do. And here's an example from my own class. In my class, I am teaching about food science and food engineering, and I do not ship materials. Students are expected to purchase some food items and have access to a refrigerator. And so the students design and implement their own experiments to demonstrate different scientific concepts. What's happening here is they're demonstrating that when you mix salt or sugar with water, it freezes less well and more slowly. Okay, so there's lots of options. And this should be controlled by the objectives you want to hit and your available time and resources, right? Like the best thing might be to do a simulation, but if there isn't one commercially available, then let's pick something that we can actually do. This is on your handout, so you can go check these out later. There are a large number of places where people have shared their materials. So this includes videos with some data. This includes simulations. This includes thought experiments. And all of these places are accessible. Some of them you must sign up for. So for example, if you go to the first website, engineeringunleashed.com, you must create a login, and they need to verify that you are faculty. But that usually takes only a day or two. And I also want to call your attention to the fact that many engineering education journals have now had or are about to publish a special edition on COVID education, which often replicates their remote teaching. So please go look at those. And I want to give you just a thing to note up in the orange box. Sometimes you are looking for something I would call turnkey. That means I use this exactly as is, and I have all the materials for it. So some of what you will find will have that level of detail. More of what you will find is B, the way I use recipes, which is I look at the recipe and I think, okay, I'll do something kind of like that. So recognize that some of these sources you'll find, you would still need to add your own interpretation to make it work for your students. And we are just about out of time, so this works. So I'm going to give you another 3 minutes. It's going to be almost the last 3 minutes here. And that's intentional. For that same laboratory exercise, what approach do you think you will try? How will it hit your outcomes? And what do you need to do to implement that approach? So take some notes. How are you going to do this for that one specific lab you were thinking of? And again, I have the terrifying timer. So take a moment and feel free to share in the chat if you like. Okay, And as time is up, I don't expect this only to require 3 minutes. So I expect that you will have to work on this additionally, but hopefully this has gotten the seed of your idea started for you. So a traditional laboratory or project experience addresses a great many objectives, but when we select the important ones we want to focus on, we can craft an experience that will address them. All right, so you have lots of options, and by focusing on your core objectives, you can make sure you hit them and not merely feel the loss of the objectives that you lose by being remote. So there are many simple and effective things you can do. And that is my, oh, look, it's not even 9:45 yet. I have a whole 30 seconds. So that is what I wish to share with you all. And I believe we're going into the Q&A session now. So thank you very much for your time and attention.
So, Professor Wellerman, one of the questions for you is how often did you review or modify, reform the existing tracks, and under what circumstances you will remove an existing track?
For this question, is my audio okay?
Yes.
Oh, okay. Yeah. With this foreseen new curriculum, we also want to have a new system in which we can decide upon changes in curriculum. So whether we want to modify a module or want to scrap it and replace it with a new one. And for that, we will use a period of 3 years to first evaluate a current module, how it operates. Are there sufficient number of students? What is about the quality? Staff, can we find staff for the module? And then in case we do not like what we see, so in case we have trouble, we can then decide after 3 years to change this module or to remove it even in the worst case scenario. So I hope that answers the question.
Yes, and continuing with this curriculum reform, some of the topics might be a bit ahead of the industry. So when that happened, how did you convince or tell students that this training is for the future that may or may not exist, as you can see right now? And how did you also tell the industry that please acknowledge the importance of our students as they might be the leading workforce, but not now? So how did you handle this?
Yeah, also a very, very interesting question. And of course, it is also the pressure we are on to, on the one hand, deliver students who are fit for the job. And actually, the industry asks for perfect fit for the first job. And we are saying, no, we want to educate our students for a longer career and make sure that they have the ability for lifelong learning. So the way we handle it is that we tell our industry, and they recognize it also, that our students are able to go on a specific item in depth and really acquire in-depth knowledge. Doesn't mean that it is in-depth all the way, but they must have the capabilities to research and to dig in a specific area on a specific item. So the level of thinking and of doing research is, I think, deeper than required in industry. We don't do that for the whole entire subject, but for a specific part we do, because this experience is most important for students. They have to understand what their capabilities are. So that's why you're at the university, I think.
Okay. Thank you. Next question is originally for Professor Kim, but I'd like to ask Liam instead. What happened if the team member have different view of the course. Some just want to barely pass it, and some want to get a straight A. So how did you handle? Should we put them in the first place, or should we regroup them? So what did you see as a team member?
Yeah, that's a great question. And what I would say as a member of the team is it's really important to kind of tailor the objective so that each student can find something that they're passionate about. Specifically with my project, I was working with nitro cold brew. I've drank coffee my whole life. I love it. It's something I'm interested in. So it was very easy for me to find that connection. For the other students who might not be as naturally interested, it was a little bit harder for us, and we had to take a little bit of a step back and think about, okay, what is it that you can really get into? Our computer engineer does a lot of programming on his own and building circuits, and not a lot of drinking coffee or caring really about any of that stuff. So what he did was, we had conversations with him and said, what are you interested? What do you want to get out of this project? And he's like, I really want to run with this. I want to see how advanced we can make our systems. And so we kind of had those conversations and talked to every single student on our team of 4 to make sure that, no matter what it was, we're figuring out what their strengths are, what their passion is, and then finding that inside of our project guideline. And then that way, nobody isn't motivated because everyone kind of has the opportunity to work on something that they really care about.
Yeah, thank you. And also back to Professor Kim, so when we do, well, I believe the majority of the students are good students, so we are pretty happy with it. But sometimes the left behind students are, that keep our memories long, so that we are kind of frustrated with the process. So so between grouping the students by themselves and also group for them, what your views on us as a faculty, try to force them into teams. What role should we play?
Yeah, these are all very good questions. I think they're vexing questions. We face them, I think, every year. I've been teaching senior design, for something like 15 years, and we run into team issues. I would say every year, and we learn just a little bit more every year, and then something else happens. With all that said, I think having conversations early, in the middle, and at the end are really important. And they all serve a different role. The conversations at the beginning is to set expectations and norms, but you can't catch everything. I think what Liam said was really insightful. Understanding that everybody has something different to bring to the team and kind of setting expectations on this is what I would really like to contribute, but also expressing a willingness to be flexible and to say that I may need to take on a role that I don't feel comfortable with, and letting that be part of the culture of the team, I think is really important as well. I think that you're always going to run into, or sometimes you will run into students who may be, I don't want to say undermotivated, but we have to be careful about reading too much into why a student behaves the way that they do. There may be many, many reasons as to why they don't seem engaged in a project. It may be that something else is going on in their lives, or it may be that they're not getting along with their team and their team has really kind of let them out in the cold. And I think that's where the middle conversations come in, and you process together both individually as well as with the team. I think myself and Professor Buffington and Professor Regent, we tend to take on a very hands-on approach, if you will, but we also are in a very small context. We only advise a few teams each. So the harmony of each team is actually quite important to us. With all that said, you still run into problems. But I think it's part of the learning process too, that you have established norms, you have these conversations in the middle, and you really hope for the best at the same time. I think about some of the teams that we have had that have been the most successful and those that perhaps have been the least successful. And I think that, again, we have to be careful about characterizing those teams as, oh, you had a bunch of superstars. And what I was talking about before is establishing that culture, but reinforcing that culture also. and realizing that the way that they interface with one another can either be toxic and it can continue to be toxic, or you can break that cycle. I've had both happen, and I think it's important to remain engaged in that way.
Okay, thank you. And Professor Buffington, would you like to add some comments?
Yeah, just a couple of quick comments just to build on what Liam and Professor Kim were saying. I think Liam's team, so I had Liam's team and another team, and Liam's team seemed to find that culture themselves. They seemed to be able to come together, agree on objectives. They could build on each other's strengths and assign tasks effectively that way. I think the other team struggled with that much more. They were not able to do that on their own. And I think my message would be this, that as Professor Kim was saying, it requires more intervention on the part of the advisor for the project. You need to try and find out early if there are problems. And one of the things that we did within this course is that we actually did peer evaluations at a couple of times throughout the semester so that we could get direct and fairly anonymous feedback from the students as to what was going well and what was going not so well. So that, you know, I know, again, for my two teams, Liam's team figured a lot of these things out on their own. Another team did not. So then it was up to me to say, here are the things that I see that are going well. Here are the things that you need to work on. You need to develop your strengths. You need to work together to develop your own sense of accountability. That's one of the things that I think is important as well, is that you can't let these, as again, what Professor Kim was saying, you can't let these problems just continue to exist. You have to do some sort of intervention. Usually, in my case, that was usually individually talking to the students and saying, you know, what is going on in your life? How do you feel about this project? How do you most want to contribute to it? How can you work best with your team?
Okay, thank you. And also for Professor Vision, for those hands-on labs that can be operated at home, one question is, can home-built experiment work in more advanced courses? And also, if some of students are not so handy, so that in some cases they have to be forced to the lab to do things, the people ask, what if they are scared of independent hands-on lab operation, and how do we motivate them?
Yeah, these are good questions. I'm going to answer the second one first. So it is helpful when having students work at home to start by having them do an activity that is highly scaffolded. So that is, we all build the same thing together. So for example, in that controls course, everyone in the class did the balance beam and talked to the professor about it before doing something more complex. So students who are hesitant, perhaps because they are afraid to do something wrong, they are afraid to break things, they are afraid of machinery, encouraging everyone to start with the same simple task and then build that up to the more complex designs can really help with that. This is, and then at home, I feel it's a very good fit for advanced courses because in the advanced courses, you can make one of the objectives be designing the system, and in ways that you could not ask an early student. So for advanced students, you can send them some pieces of equipment, such as a Arduino, and ask them to fabricate the rest of their system themselves, as opposed to some earlier students where you would really want to provide a much more complete equipment list. So I think it can work quite well.
Okay.
There are some things, I will admit, that are not safe to do at home. And that's when we have to go to video. You know, there's some chemical reactions people should not be doing in their kitchen. It's true.
Yeah, we'd like to hand it over to Professor Zheng, as he will be retiring by the end of this month. So we're gonna celebrate the journey that he brings us. So I, take the time back to Professor Zheng.
Thank you. Time is running late. I hope that everyone enjoy the presentations and discussion as much as I did today. Hopefully, in the future, we can organize similar types of forums. And this type of enthusiasm for engineering education can continue. Yes, I will be retiring in 15 days, something like that. For now, I would like to thank everyone for participating in the forum. Well, Professor Zhang and Professor Yang will continue to be the leader of this project. So should be okay. Wish everyone good health, and the COVID-19 pandemic will go away soon. Thank you, and bye-bye.
Thank you. Thank you. Have a good
Bye-bye.
night.